In today's video, we're going to cover section 8.5, three theorems involving proportions. After studying the section, you'll be able to apply three theorems frequently used to establish proportionality. In this section, we'll be introduced to three theorems that will be useful in a number of applications. Our first theorem: if a line is parallel to one side of a triangle and intersects the other two sides, it divides those two sides proportionally, and this is the side splitter theorem. So looking at our example, we're given that BE is parallel to CD. If BE is parallel to CD, then we can use our side splitter theorem to show that AB over BC would be equal to AE over ED, because here in our theorem it says it splits the sides proportionally, so I would keep the sides together. So looking at this, we'd have AB over BC is equal to AE over ED. Now I can prove this using similar triangles and substitution, but we won't show that proof. Looking at our next theorem, Theorem 66, if three or more parallel lines are intersected by two transversals, the parallel lines divide the transversals proportionately. Looking at this in our example, if AB is parallel to CD, which is parallel to EF, and I have the transversals AE and BF, then I would have this theorem where my parallel lines are split proportionately, where AC over CE would be in proportion to BD over DF. Now I can prove this theorem using similar triangles and substitution. I would first need to draw in another transversal AF to give me these similar triangles. Now looking at our last theorem, Theorem 67, if a ray bisects an angle of a triangle, it divides the opposite side into segments that are proportional to the adjacent sides. This is the angle bisector theorem. So if we're given triangle ABD and ray AC bisects angle BAD, telling me that angle 1 is congruent to angle 2, the angle bisector theorem would tell me that the sides that are opposite the angle, so BC over CD, would be proportional to the adjacent sides, so AB over AD. So BC over CD is equal to AB over AD. Now looking at our sample problems, we have problem 1. Given line BE is parallel to line CD and the lengths is shown, find segment ED and segment CD. So if I want to find segment ED, notice I have BE parallel to CD, so then I could use the side splitter theorem to set up the proportion AB over BC is equal to AE over ED. Now if we call ED X and set up my proportion, I'd have 4 over 2 is equal to 7 over X. Now using my means extremes product theorem to multiply out, I'd get 4x is equal to 14. I divide by 4, so x is equal to 3.5. So the length of ED is 3.5. Now let's find the length of CD. So CD is my bottom segment down here. Let's call that Y. I can't use side splitter theorem here, but if my lines are parallel, that would give me similar triangles. So triangle ABE is similar to triangle ACD. So I could set up a proportion of their sides to solve for Y. Setting up this proportion, I'd have AB, which is 4, over AC, which is 6, because 4 plus 2 is 6. That's equal to 6, which is BE, over Y, which is CD. Now, if I use my means extremes product theorem to multiply this out, I'd get 4y is equal to 36. Dividing everything by 4 would get me y is equal to 9. So the length of CD is 9. Looking at problem 2, we're given A parallel to B, parallel to C, parallel to D. The lengths is shown. KP is 24. I want to find KM. So here I have multiple parallel lines with two transversals. I can use Theorem 66, which states if I have 3 or more parallel lines with two transversals, the parallel lines cut the transversals and divide them proportionately. So if FG, GH, and HJ are in the ratio of 5 to 2 to 8, then KM, MO, and OP will be in the ratio of 5 to 2 to 8. Now KP, this whole segment, is 24. I don't know exactly what KM, MO, and OP are, but I can say that it would be 5x, 2x, and then 8x. Because if I solve for x, those would still be in proportion to FG, GH, and HJ. So if I say 5x plus 2x plus 8x, that's 15x. That's going to be equal to the whole side, which is 24. I'll divide by 15 to get me x is equal to 24 over 15. Simplifying this would give me 8/5. Now I know Km was the 5x, so Km being 5x would make it 5 times 8/5. 5 times 8/5 is just 8. So the segment Km is 8. Looking at problem 3, we're given angle RVS is congruent to angle SVT and the lengths as shown. I want to find side ST. So if angle RVS is congruent to angle SVT, that tells me that ray VS is an angle bisector. So I could use my angle bisector theorem. Remember, the angle bisector theorem told me that the sides opposite the angle are in proportion to the sides adjacent to the angle. So I could say 4 over x would be equal to 8 over 10. Now, if I use my means extremes product theorem to multiply this out, I'd get 40 is equal to 8x. I divide by 8 to give me x is equal to 5. So ST is 5. Looking at problem 4, we're given line XA is parallel to line YZ. Angle XAY is congruent to angle XYA. I want to conclude that WX over XA is equal to WA over AZ. So WX over XA is equal to WA over AZ. Now, if I'm given that XA is parallel to YZ, I would have the side splitter theorem, which would tell me that WX over XY is equal to WA over AZ. So if I can show that XY is congruent to XA, then I could use substitution to have my conclusion. Now I'm also given that angle XAY is congruent to angle XYA. Therefore, I'd have XY congruent to XA because if base angle is congruent, then legs congruent. Then I could use substitution to get my conclusion of WX over XA is equal to WA over AZ. So looking at this in my statements and reasons, I'd have my given. Then I use side splitter theorem to show WX over XY is equal to WA over AZ. Then I had my second given. Then I had base angles congruent, then legs congruent, so XA is congruent to XY. Then I used substitution to get my conclusion of WX over XA is equal to WA over AZ. In today's lesson, we learned 3 theorems involving proportions that include the side splitter theorem, parallel lines and 2 transversals theorem, and the angle bisector theorem. That's a wrap on today's video. We'll see you in the next one.